start recording.
Yes, first start recording and then you can start sharing.
Now is that okay, sir? I have started.
Sharing.
Sandeep sir.
Sir, start sharing.
Uh, Are you able to see the
Yes.
screen, sir? Hello.
Yes, I'm able to see.
Uh, My voice is clear, sir.
Yes, yes, it is.
Hello.
Your voice is clear, sir.
Shall I start now?
Yes, just check. Use 86. Just wait for another minute or two and you can start.
Your voice I am unable to hear, sir.
Sir, there are 86 students. Just wait for a minute or two and then you can start.
I should wait for 2 more minutes.
Yes, strength is. Yes.
Okay. Just inform me so that I will start.
So I think you can start. Hello. Balakrishna, sir, you can start.
Sir. Sandeep sir, shall I?
Yes, sir.
Okay, I'm starting. Good morning, everyone. Uh, this is your M2 regarding the revision. So I'll be just revising the first unit. So if you remember in your syllabus, the first unit is related to the ordinary differential equations. So in this first unit, you have two parts. First part is related to ordinary differential equations of first order, first degree. Whereas the second part is related to ordinary differential equations of first order but higher degrees. Okay. So in the first part, we'll be having the problems related to the exact differential equations, non-exact differential equations, linear differential equation, Bernoulli differential equation, and applications of the ordinary differential equation. Okay, so basically in the exam, mainly he will always concentrate more on the application point, that is Newton's law of cooling and Newton's law of growth or decay. So to solve that one, basically you should know the previous things, that is how to find the solution for a exact differential equation, non-exact differential equation, and linear and Bernoulli. So as you will be given the problems in the form of bits, 5 marks, compulsory you will have one 5 mark question from any one of these methods, that is exact, non-exact, linear, Bernoulli, and the another 5 mark question will be from the application point, that is Newton's law of cooling or growth or decay problem. And the second, from the second part, that is ordinary differential equations of first order and higher degree. So there you will be having that solvable for p, y, and x. So basically they are also simple and small problems. So question will be always in the form of A and B bits. 5 marks questions will be there. Okay, so just we'll revise the first part of this first unit, that is ordinary differential equations of first order and first degree. So if you see my screen, so there we are having the basic definition, differential equation. So if you remember, differential equation is nothing but an equation which is having the derivatives of a function with respect to one independent variable or more than one independent variable. So basically, differential equations are classified into two types, that is ordinary differential equation and partial differential equation. So in our syllabus we are having the ordinary differential equation, so we'll be having that one. That is, a differential equation is said to be an ordinary if it has the derivative of a function with respect to single independent variable. That means you will be having the differential equations for the functions which are in the form of y is equal to f of x. That means one independent variable only. So when the function is there with more than one independent variable, there you will be having this second type, that is partial differential equations. So that is a differential equation which it contains the derivatives of a function with respect to more than one independent variables. Okay, so but our syllabus is related to ordinary, we'll see that one only. Okay, so the basic things, the order is nothing but the highest derivative of the differential equation, and degree is nothing but the power of the highest derivative of the differential equation. So okay, directly I'm going to that exact differential equations. Uh, So basically, our syllabus is related to first order, first degree. The general form of a first order, first degree ordinary differential equation will be either in the form of dy by dx is equal to a function in terms of xy, or it is in the form of m is a function in terms of xy into dx plus n a function in terms of x and y into dy equal to 0. So it may be any one of these forms, either dy by dx is equal to f of x comma y, or m dx plus n dy equal to 0, right? So now exact, so our problems are related to exact differential equation. Okay. Basically he will be always asking define exact differential equation, then he will giving a problem. So definitions are also important. So if you see there, a differential equation which is obtained from its solution by direct differentiation without any further transformations is called an exact differential equation. That means a differential equation which is obtained from its solution. But here we don't know what is the solution first of all, right? So when you have the solution of a differential equation, and if you differentiate that one, if you are going to get the differential equation, then you will be saying it is an exact. But we don't know how to find the solution for the differential equation. So that is the reason we can also define in another way, so, like this. A differential equation which is in the form of first order first degree, that is m dx plus n dy, is said to be an exact if there exists some function called as f such that dou f by dou x is equal to m, dou f by dou y is equal to n. Okay, so when you have a function, okay, if you partially differentiate with respect to x, if you are getting that m function of the differential equation, and when you are differentiated with respect to y partially, if you are getting n of that differential equation, then also you can say. Okay, but here also one is the problem, so how to find that function? Okay, so basically this is the definition, but to find the solutions we are given a condition called as necessary condition for exactness. Using this condition we'll be solving our problems. Okay, to say a given differential equation of first order first degree, that is m dx plus n dy equal to 0, is an exact, it should satisfy a condition called as dou m by dou y is equal to dou n by dou x. When this condition is satisfied, then that first order first degree is said to be an exact. So always you are supposed to verify this condition. If it is satisfying, you will be saying it is an exact. So if it is an exact, whose general solution will be like this. You should integrate that m function with respect to x, treating the y terms as constants, plus you should integrate that n function with respect to y, which is free from x terms. So in this n function, you should consider the terms where it is free from the x terms, and you should integrate with respect to y. Okay, this is the general solution for an exact differential equation. Okay, so just one example, if you see there, you have a problem there. Solve 2x plus e power y dx plus x e power y into dy equal to 0. So if you see this question, it was directly there in the form of m into dx plus n into dy. So a function in terms of xy, here a function in terms of xy. So generally he may go always in this format, or sometimes he may not give directly in this format. That means m dx plus n dy equal to 0, or he may give in the form of dy by dx is equal to f of x comma y. Okay, so whenever you are given, try to express that equation into m dx plus n dy equal to 0. Once you express that one, so just check for that exactness, that is dou m by dou y is equal to dou n by dou x or not. So here m function is 2x plus e power y, n function is x e power y. When you differentiate that m partially with respect to y, so this 2x becomes 0, and derivative of e power y is e power y. And here n function with respect to y, sorry, with respect to x, so e power y remains constant. So derivative of x is 1, so it is e power y. So here dou m by dou y and dou n by dou x both are same, so the given equation is said to be an exact differential equation. So therefore its general solution is given by integrating that m function with respect to x, treating y terms of that m as constants, plus integrating that n function with respect to y, which is free from x terms. Okay, so here m function is 2x plus e power y into dx n. So if you see here, n is x e power 5. Here in this n function, only one term is there which is having x term. So this term is not free from x. So therefore, in this n function, there is no other term which is free from x. So therefore, we'll consider as 0. There is no terms which are free from x. That is the reason here n is considered as 0 and integrated. So integration of 2x is 2x square by 2 plus e power y. So as we said that y should treated as constant, this e power y treated as constant. So integration dx is x, and this is 0. Like this you will be having. So if you see here the second one, so dy by dx is equal to a function is given. That means this is in the form of dy by dx is equal to f of x comma y format. So to find the solutions, you need to express that into in the form of m dx plus n dy, right? This is about the exact differential equation. Now we'll see the other case, that is non-exact. Okay, so solutions to the non-exact. Suppose if the given first order first degree mdx plus ndy is an non-exact, that means when you will say a non-exact, if it doesn't satisfies that condition, dou m by dou y is not equal to dou n by dou x. Yes, I will send this PPT also, and also I'll forward the questions related to the first unit for the practice sake. Okay, some of your friends are asking to share this notes. I'll send this one. Yes, I will also start the second unit revision, but may not be possible today. So tomorrow I'll just start that second unit revision. Okay. Now, so non-exact. So when you will say a non-exact, if it is dou m by dou y is not equal to dou n by dou x, then we will say that it is non-exact. So to find the solutions for non-exact differential equations, there is no particular procedure. So only thing is you have to change that or reduce that non-exact into exact format. So once you reduce that into exact, you should follow that procedure what you have solved for exact case. That means integrating the m function with respect to x, treating y terms as constants, plus integrating the n function with respect to y, which is free from x terms. For that, first of all, you have to reduce that into exact. So to reduce that into exact, we are supposed to multiply with a function called as integrating factor. Okay, so here how to find that integrating factor is the important point for us. So because we don't know exactly how what is that integrating factor, so to find that integrating factors we are given some methods are there. First method is a basic method where we'll be directly writing that integrating factor by using this basic definite derivatives. Okay, so dy derivative of xy is x dy plus y dx. Like the derivative of x by y is same as like what you have gone for uv rule and u by v rule. So these are the some basic things which you have already gone through. Okay, so basically for 5 marks question generally we will not have a problem based on this first method. So that is the reason I'm just skipping this one. I'll be going for the second one. That is, if mdx plus ndy is a non-exact differential equation and if it is a homogeneous form. So if that is a non-exact and homogeneous, then its integrating factor is given by 1 by m into x plus n into y, where that mx plus ny is not equal to 0. So first of all what you have to see whether it is exact or not. If it is non-exact, you have to reduce that into exact. So to reduce that into exact, you should multiply that equation with respect to its integrating factor. How to find that integrating factor? First of all, you have to see whether the given equation is a homogeneous equation or not. So homogeneous is nothing but you should see the degree of the each term of that equation is same or not. Okay, now if you see here, first question, solve y minus x dy by dx is equal to x plus y dy by dx. So he has given an equation which is in this format, which is not directly in the form of m dx plus n dy. You should reduce that into m into dx plus n into dy. So when you reduce, it will be in the form of y minus x dx minus of x plus y dy. So here m is this one, n is this one. As it is reduced into m dx plus n dy, so first of all check whether it is exact or not. So first step you need to check for exactness. That is m is what here, it is in y minus x, n is what here, minus of x plus y. So dou m by dou y, so partially if you differentiate this with respect to y, it is 1 and this is 0, and with respect to n with respect to x. So when you differentiate this one, minus 1 you will have. So dou m by dou y is 1, dou n by dou x is minus 1, which is not equal to, which means given equation is non-exact. If it is non-exact, we should find its integrating factor. So if you see here the this one, so degree of each term of this equation, so degree of this y is 1, degree of this x is 1, degree of this x is 1, degree of this y is 1. That means degree of each term of that equation is same 1. As the degree of each term of that equation is same, we'll say it is homogeneous. So therefore, as it is non-exact and homogeneous, its integrating factor is given by 1 by that m function into x plus n function into y, where m is here y minus x into x plus n is here minus of x plus y into y. So when you simplify that one, we are having minus of 1 by x square plus y square. So this is the integrating factor. So once you have this integrating factor, you should multiply to that given equation. When you multiply that one, so like this, minus 1 by x square plus y square into that m dx plus n dy equal to 0. When you multiply, it will be in the form of like this, that is x minus y by x square plus y square dx, and this will be x plus y by x square plus y square into dy equal to 0. Once you multiply that integrating factor to the non-exact, it will be always unexact. So no need to check once again for the exactness. Directly you can go for its solution. So it is once again in form of m dx plus n dy equal to 0, right? So as this multiplied with the integrating factor, this equation is said to be an exact. Once it is an exact, its a solution is given by integration m dx plus n dy, where here m, in m y terms are treated as constants, n terms, n should be considered without x terms. So here this is the m function and this is the n function. So m is x minus y by x square plus y square dx plus integration n. N is x plus y by x square plus y square. Even if you split, it will be in the form of x by x square plus y square plus y by x square plus y square. That means first term contains x term, second term also having the x term. That means in this n function, there is no term which is free from x. That is the reason we will consider n as 0 here. Once you have like this, evaluate this integration. So integration of this one x by x square plus y square dx, split it, that is minus integral y by x square plus y square dx, right? So as you know the integration f dash by f of x format, that is derivative of x square plus y square is 2x, but here 2 is missing, so multiply and divide with the 2, so it will be in the form of f dash by f of x. So according to that, integral f dash by f of x is log f of x, that is log of x square plus y square. And this term, as we are integrating this one with respect to x, treating y terms as constant, so here y remains constant, that is integration of 1 by x square plus a square format. So it is nothing but 1 by a into tan inverse of that x by a, right? So applying that one, you will get this one. Clear? Okay, so this is about the non-exact case. Once you have that non-exact differential equation, you should reduce that into exact. For that, you should multiply with its integrating factor. So to have that integrating factor, you need to check whether it is homogeneous or not. If it is homogeneous, its integrating factor will be 1 by m into x plus ny, 1 by m into x plus n into y. So using that, you can get the solution. Okay, this is about that first case. Like that, let us go for the third method, that is to find that integrating factor for non-exact differential equation. Okay. Okay, if suppose the given equation is in the form of y into a function in terms xy terms plus x into another function in terms of xy. Okay, so if suppose first order first degree differential equation which is in this format and non-homogeneous, then its integrating factor will be 1 by mx minus ny, right? So just see this one clearly. This solve this one, solve y into 1 plus xy dx plus x into 1 minus xy dy equal to 0. So here m is y plus xy square, n is x minus x square y square. Check for that condition, dou m by dou y is equal to dou n by dou x or not. So when you do with respect to y partially, derivative of y is 1 and x remains constant, derivative of y square is 2y, so it is 1 plus 2xy. N with respect to x partially, derivative of x is 1, derivative of x square is 2x minus 2x, and y remains constant. So both are not same, so therefore it is non-exact. And see whether it is homogeneous or not. See here, m is having y plus xy square. The degree of y is 1. Degree of this xy square is 3. And the degree of x is 1 here. And degree of x square y is 3. That means degree of each term is not same. As the degree of each term is not same, so it is a non-homogeneous equation. So non-exact, non-homogeneous. And if you can split in the format y into a function xy plus x into a function xy, then you can have the integrating factor as 1 by m into x minus n into y, right? So directly you are given question itself, a y into a function in terms of xy like that, plus x into a function in terms of xy terms. So here you can ask me that 1 is there. That means you can treat this as x power 0, y power 0, right? Like that, this is x power 0, y power 0. That means this is a function in terms of xy terms. Okay, this is a function in terms of xy. Okay, as this is non-exact, non-homogeneous, and it is in the form of this format, so therefore integrating factor is 1 by mx minus ny. Okay, so here 1 by m is y plus xy square into x minus n is x minus x square y into y. When you simplify this one, you are having 1 by 2x square y square. So this is the integrating factor for the differential equation. So to reduce that into exact format, you should multiply the given differential equation, that means this one, into with this integrating factor, that is 1 by 2x square y square. So just multiply to that one, so that you will be having something in this format, that is here y gets cancelled, so it is 1 by 2x square y, plus here xx gets cancelled, and y square gets cancelled, so remain with 1 by 2x. Like that, here xx gets cancelled, it is 1 by 2x y square, and here x square and y gets cancelled, it will be 2y. Now, this is the mdx plus ndy format, which is clearly an exact differential equation. Once you multiply with its integrating factor, that will be an exact differential equation. As it is a different exact differential equation, so its solution is integrating m function, that means this function, with respect to x, treating y terms constants, plus integrating this n function with respect to y, which is free from x terms. Okay, so here m is 1 by 2x square y plus 1 by 2x, and n. So if you observe here, this is the n function. In the two terms are there. First term is having this x term, right? Second term, it is 1 by 2y minus 1 by 2y. So in the second term, there is no x term, whereas in the first term, you have this x term. So you should consider the n function which is free from x terms. So in this n function, this is the term which is free from x. So therefore, you should consider as minus 1 by 2y over here. Whereas in the previous cases, we have there is no term which is free from x. So we took it as 0. So like this. Now, integration of this you should do. So this with respect to x, this with respect to y. As you are here integrating with respect to x, y treated as constant. So 1 by 2y remains constant outside. So integration of 1 by x square is minus 1 by x. And here 1 by 2 remains constant. Integration of 1 by x is log x. And minus 1 by 2 remains constant outside the integration. Integration of 1 by y is log y. So once you have like this, just simplify it so that you will get the answer. Is that clear now up to here? Is it clear? So what we have gone here, we have gone for solution for an exact differential equation. Suppose if it is non-exact, you should reduce that into exact. For that, you should multiply with its integrating factor. So how to find that integrating factor? First case, if it is homogeneous, it is 1 by m into x plus ny. If it is non-homogeneous and can be expressed in the form of y into f of xy plus x into g of xy dy, then its integrating factor will be 1 by m into x minus n into y. Clear? So next case, if you see there, next one, suppose if it is not satisfying those two, that is, if it is non-homogeneous and cannot be expressed in the form of y into f of xy plus x into g of xy, then you should check for this next one, that is 1 by 1 by n into dou m by dou y minus dou n by dou x is purely a function in terms of x only. So if this condition satisfies, its integrating factor is given by e power integral that f of x dx. Okay. So now see this example. So this is the differential equation. So clearly m is here x square plus y square plus 1, n is minus 2xy. So if you see here, degree of this term is 2, this term is 2, but this term is 0. And here degree is 2. So all the terms are degrees 2, but this 1 degree term is 0. That is, degree of each term is not same, which is clearly non-homogeneous, right? So if you consider y outside, will you have a function in terms of xy? No, right? Because here it will be x square by y, here it will be y, and plus 1 by y you will have. That means we cannot get in the form of y into f of xy plus g into x into g of xy. So therefore, as it is non-exact, non-homogeneous and cannot be expressed, we should check for this condition, that is 1 by n into dou m by dou y minus dou n by dou x, right? So n. So in this equation, n is what? Minus 2xy. So that is 1 by minus 2xy into dou m by dou y minus dou n by dou x. Dou m by dou y is 2y, dou n by dou x is minus 2y. So 2y minus of minus plus 2y, that will be 4y. So when you simplify this one, 4y by 2xy, so you'll be remained with minus 2 by x. 2 gets cancelled, so here 2 remains, and this y gets cancelled, denominator x remains, minus is there, so minus 2 by x. So purely it is a function in terms of x only. So minus 2 by x, purely a function in terms of x. As it satisfies this condition, so its integrating factor will be e power integral f of x dx, where f of x we have minus 2 by x. If you apply here, minus 2 remains constant outside, integral 1 by x is nothing but log x, that is e power minus 2 log x, which is nothing but e power 2 into e power minus 2 into log x, that can be written as e power log x whole power minus 2. Okay, so e power log x power minus 2 is nothing but x power minus 2, that is 1 by x square. So its integrating factor is 1 by x square. You should multiply to that equation, you should multiply to this equation, that is 1 by x square into that equation is what? X square plus y square plus 1 into dx minus 2xy dy equal to 0. Multiply that one. X square gets cancelled 1. Here y square by x square plus 1 by x square dx minus xx gets cancelled. Remain with minus 2y by x dy equal to 0. As you are multiplied with integrating factor, that equation which is non-exact changes to exact, where m is this one and n is this one. So as it is an exact, general solution is m dx, integrating m function with respect to x, treating y terms constant, integrating n function with respect to y, which is free from x terms. Now if you see here, once again here, n is minus 2y by x. Only one term is there in which x is involved. So that means there is no terms which is free from x. So therefore, we will be considering n as 0 over here and evaluating this integration. Integration of 1 is x, y square treated as constant outside, integration of 1 by x square is minus 1 by x. Like that, integration of 1 by x square is minus 1 by x, and here this is 0, therefore it will be 0. So when you simplify, you'll have this one, right? So the last one, once again, the same thing. If it is non-exact, non-homogeneous and cannot be expressed in the form of y into f of xy plus x into g of xy, and if you are unable to get purely a function in terms of x, then you should go for this next one, that is 1 by m into dou m by dou y minus dou n by dou x is purely in terms of y or not. See, there are two cases are there. Suppose if you go as it is like this, dou m by dou y minus dou n by dou x, so if it is purely in terms of y, integrating factor will be e power, you should consider minus. Or if you write like this, 1 by m into dou n by dou x minus dou m by dou y, which is purely in terms of y, integrating factor is e power g of y. No need to consider minus here. But when you go for this one, dou m by dou y minus dou n by dou x, you should always take minus. If you go for like this, dou n by dou x minus dou m by dou y, no need to have this one. This is up to you, whichever you feel comfortable, you can remember that one. As I'm going for this one, because In the previous case also have gone for dou m by dou y minus dou n by dou x, 1 by n into dou m by dou y minus dou n by dou x. So that is the reason once again I'm following that one only. Just I'm going with minus sign with here. Is that clear? Is that clear? Okay, just see one more example. Same. So solve this one. Y square y plus y square dx plus xy dy equal to 0. Okay, so once again it is in the form of mdx plus ndy equal to 0. So check for the exactness. M is y plus y square, n is xy. So dou m by dou y is 1 plus 2y, dou n by dou x is y, which is not equal to, which is clearly non-exact. C for homogeneous, degree of y is 1 here, degree of y is here 2, degree of xy is 2. So degree of the terms of this equation are not same, 1, 2 and 2 not equal to, so therefore non-homogeneous. Can it be, when you consider y as common outside, it will be y into 1 plus y. That means this is not a function in terms of xy terms, 1 plus y purely in terms of y, which means you cannot express into this is second part. So check for the, how should we know that we have to apply method 4 or 5. See, one of your friend is asking how should we know that we should apply method 4 or 5. So that is what I am saying here. Directly we cannot decide here. You should just go through step by step. That means once it is given, if it is non-exact, see whether it is homogeneous or not. If it is non-homogeneous, then check for this y into f of xy plus x into g. So in this case, when you write y outside, we cannot have in the form of y into f of xy. So once it is not satisfying this one, you should check for this condition. So 1 by n into dou m by dou y minus dou n by dou x is purely in terms of x or not. If suppose once again it is not in this purely x term, then you should go for 1 by m into dou m by dou y minus dou n by dou x. So there is no other alternative where you can directly go for method 4 or 5. So you need to check one by one over here. Okay, so here that is the reason. If you see in this example, so I'm, as it is non-exact, non-homogeneous, cannot be expressed into in this format. I'm just verifying this one, that is 1 by n into dou m by dou y minus dou n by dou x is purely in terms of x or not. So when I go for this one, n is xy, so that is 1 by xy, and dou m by dou y is 1 plus y minus dou n by dou x is y. So which is in the form of like this 1 plus y by xy, where this y terms cannot be removed. That means this is a function in terms of xy, which is not purely in terms of x. As this is not satisfying, you should go for this next condition, that is 1 by m into dou m by dou y minus dou n by dou x. So m is here 1 by y plus y square, and dou m by dou y is 1 plus 2y minus y. So when you simplify this one, 1 plus y by and y. So in this denominator, if you consider y outside, it will be y into 1 plus y. 1 plus y, 1 plus y gone. So remained with 1 by y. That means you have purely in terms of y. Therefore, its integrating factor will be e power c here minus I am going, because I consider dou m by dou y minus dou n by dou x. So I should go with minus of integral g of y dy. If I go like this, dou n by dou x minus dou m by dou y, no need to go with this minus n. This is up to you, whichever you feel comfortable, you can remember. Okay. So, but don't get confused over here. So as I'm following this over here, so here also I'm just considering same as it is, just I'm considering with minus n. Am I clear? Am I clear here? So some of your friends asked, so can we go for directly method 4 or 5? So method 4 and 5 we cannot go directly. Okay, please. So there is no alternative for us. So we need to check one by one. So that is the reason. So first to see whether it is non-homogeneous or not, whether it is expressed into in this format or not. Then check for this condition such that it is purely in terms of x or not. If it is not satisfied, then you should go for this condition. Okay, So its integrating factor is e power minus integral that g of y dy, that is 1 by y. So integration of 1 by y is log y. So therefore it is 1 by y. So integrating factor for this given differential equation is 1 by y. Multiply to that equation so that it will be in the form of 1 plus y dx plus x dy equal to 0. As it is multiplied with the integrating factor, this will be an exact differential equation. So it's a solution integrating m function with respect to x plus n integrating n function with respect to y without x terms. So here n function is x, only one term which is x, no other terms which is free from x. Therefore, you should treat as 0. And m function is 1 plus y. Integrating this with respect to x, treating y terms as constant. So here integration 1 dx is x, y is treated as constant. Integration dx is x, that is x plus xy equal to c. Okay, is this clear? These are the methods which you need to follow. So once again I'm reminding, we cannot directly go for any method. So you need to check one by one from the given question whether it is exact. So directly solution, if it is non-exact, then check whether it is degree of the terms are same or not, homogeneous case. If degrees are not same, then check for the expression of that y into f of xy plus x into g. If it is not possible, then check for the next condition, 1 by n into dou m by dou y minus dou n by dou x purely in terms of x or not. If it is not, then you should check for 1 by m into dou m by dou y minus dou n by dou x purely in terms of y or not. So like this you need to do. Clear? So one of your friend is saying in few problems, even if the question is not homogeneous, we use one at method. Why? I didn't. One at method means first method you are saying. Are you saying this 511? It is first method you are saying, right? So that is what I am saying. First, we are given there the methods, that is direct method. First method is nothing but the direct method. So if you can use those things directly, you can solve over itself. That is what I told you there. The first method is the basic things where you can apply directly over there, when you can express the given problem into in that format, that is derivative of xy, x into dy plus y into dx. If you can express like that directly, you can apply and you can do there. Okay, so alternate to that, these are the methods we are saying we are having. Okay, is that clear? 511. 511, is that clear? Okay, fine. So in this the next problems, basically in the main exam, in generally you will be always having a problem either from linear or from Bernoulli. So generally 90% he will always ask one bit from the application point, that is Newton's law of cooling of growth problem. The other in generally you will be having from either linear case or Bernoulli case generally. Okay. So what is this linear differential equation? Okay. So linear differential equation a linear differential equation, if it is having the first degree and no product to the derivative occurs, generally we'll say that one. That means a differential equation of first degree and first order dy by dx and no product to the derivative occurs. Like if you see dy by dx plus a function in terms of x into y is equal to q of x. So there is no product to the derivative dy by dx. So the general forms of linear differential equation are given in two formats. One is in y, one is in x. That is dy by dx plus function in terms of x into y is equal to function in terms of y, which you will be saying as linear differential equation in y. And the other one is dx by dy. That means independent variable will be x. First case, first case independent variable is x, second case independent variable is y, right? So dx by dy plus a function in terms of y into x is equal to function in terms of y is nothing but called as a linear differential equation in x. Okay, so same as like previous thing, but thing is we are supposed to find that integrating factor over here, which will be nothing but e power integral that p of x dx. Suppose if the given equation is a linear differential equation in y, that is dy by dx plus p of x into y is equal to q of x. Okay, so its solution is y into integrating factor is equal to integration that q of x into integrating factor with respect to x. So what is that integrating factor is e power integral that p of x into dx, right? Similarly, when it is in the form of dx by dy, right? So linear differential equation in x, right? So it is x into integrating factor integral that q of y into integrating factor into dy. So here integrating factor is e power integral that p of y. Okay, just see one example. We are given this first order first degree differential equation in this format, dy by dx is equal to this one. So here generally many of the students will get struck over here, like it is in the form of dy by dx into a function in terms of xy. So many of them will directly try for m into dx plus n into dy equal to 0, check for exactness, and they will do. So that is also possible if you can express that into mdx plus ndy equal to 0, and if you can simplify you can also get the answer. But so there is the other form, that means you can reduce that given differential equation into in the form of this linear differential equation dy by dx plus a function in terms of x into y is equal to q of x. See here once again I'm reminding you, whenever a question is given, he will not specify whether it is a linear differential equation or whether it is a Bernoulli differential equation or exact. It is our duty to identify that one. So generally, our as we have got habituated that when a differential equation is given, we will be expressing that into m into dx plus n into dy equal to 0, checking for the exactness and for non-exactness, like that we'll be doing. So that is the original procedure, you can follow like that. But always try whether you can express that into linear form or not. So if you can express that into a linear format, then directly go for this linear form of the solution. Okay, so here you can express this into by cross multiplying like this. Okay, so you can express that into mdx plus ndy equal to 0, and you can also do like that. But you can try for the linear case as I was telling you people. So generally maximum he will ask for linear problem or Bernoulli problems. That is the reason try for verifying whether it is expressed into in the form of dy by dx plus a function into a function in terms of x into y is equal to purely a function in terms of x. If you can express, always try for this linear form and solve the problems. Okay, so here splitting this one so that it will be in the form of minus x by 1 plus sin x minus y cos x by 1 plus sin x, so that we can write this one is dy by dx plus a function into y, function which is in terms of x into y is equal to purely a function in terms of x, as it is in the form of dy by dx p of x into y is equal to q of x. We can go for the solution for that linear form. Okay, so here p of x is cos x plus cos x by 1 plus sin x, and q of x is minus x by 1 plus sin x, right? So its integrating factor is e power integral p of x, where p of x is cos x by 1 plus sin x. So it is in the form of f dash by f of x. Derivative of 1 plus sin x is nothing but cos x. So 0 plus derivative of sin x is cos x. So as it is in the form of f dash by f of x, it is log of f of x, that is 1 plus sin x, which is nothing but 1 plus sin x. So integrating factor is this one. So general solution for this linear differential equation is y, the dependent variable y into integrating factor is equal to integral q of x into integrating factor with respect to x. So y into integrating factor is 1 plus sin x is equal to integral q of x is minus x by 1 plus sin x into integrating factor is 1 plus sin x. 1 plus sin x, 1 plus sin x gone. So we will remain with minus x. Integration of minus x is minus x square by 2. This is that solution. Clear? So if you know the solution to find linear differential equation, then Bernoulli is over, because Bernoulli equation is same as it is the solution how to find this linear. Only one step extra you will be doing. Okay, so very important. Generally you will be always going asking for the Bernoulli problems. So same as it is, if you see the general form of Bernoulli differential equation in y is same as linear differential equation in y, that is dy by dx plus a function in terms of x into y is equal to q of x. Extra term is that y power n you will be having. So here solution to find this one is reducing this one into linear form. How to reduce? By removing this y power n. So to remove this y power n, you should divide with y power n on both sides. When you divide, so here dy by dx is multiplied with 1 by y power n, which is not a linear form because product to that dy by dx is existing. That is the reason we'll be once again reducing this one, okay, by treating that 1 by y power n minus 1 as t. So this procedure is there, which is no need for us. Directly you can remember like this. Whenever you have a Bernoulli differential equation in y, so reduce that into linear form as like this. That is in place of y you will be having t dt by dx plus 1 minus n. N is nothing but this y power n. So 1 minus n into p of x. Whatever that p of x is there, that p of x will be written there. So 1 minus n into p of x into dependent variable y changes to here t is equal to that q of x into 1 minus n. So try to remember this one, then it will be over. Otherwise you need to remember this process by dividing this equation with y power n and treating this 1 by y power n minus 1 as t and changing this dy by dx into this 1 by y power n as dt by dx. Like this you will be having. Okay, so it's better to remember this one. So whenever Bernoulli is given, so it is changed into linear by changing that y in terms of t, that is dy by dx as dt by dx plus p of x into that 1 minus n in terms of y it is t is equal to q of x but into 1 minus n. Okay, please always try to remember, as it is the linear differential equation in terms of t. Okay, integrating factor will be e power 1 minus n into p of x. Okay, e power integral 1 minus n into p of x dx. So general solution will be, as it is dependent variable t, so it will be t into integrating factor is equal to, there we used to write p of x, here you will be writing 1 minus n into that p of x. So this q of x we will be writing there. Here it is 1 minus n into that q of x into that integrating factor. Just see one example here. So we are given like this, x into dy by dx plus y is equal to x square into y power 6. So this dy by dx plus y by x is equal to x into y, because as a product to the dy by dx is there, you should always remove that one. For that sake we are dividing this with x, so that it will be dy by dx plus y by x, x cancel xm. Now if you see here, it is clearly in the form of dy by dx plus 1 by x. 1 by x is nothing but a function in terms of x into y is equal to q of x, that is x into y power n. So here n is 6 here, so n can be taken as 6 here. Q of x is x, p of x is 1 by x. So reducing that one into linear form, you should divide that y power n, that is y power 6. So no need to do this one directly. If you can remember, you can directly write like this, dt by dx plus 1 minus n into p of x into t is equal to q of x into 1 minus n, right? So where t you need to remember, t is nothing but 1 by y power n minus 1, that is 6 minus 1, that is 5. 1 by y power 5 is equal to t. This you need to remember this one. Okay. So here dt by dx 1 minus n is, so 1 minus 6 is minus 5, that is minus 5 into p of x is 1 by x, that is 1 by x into t is equal to q of x is what here, x into 1 minus n is minus 5. So that is 1 minus n into q of x, 1 minus n into p of x into t. So this is the term, right? Is this clear? Am I clear this one? So Bernoulli, whenever you are given, you should reduce that into linear form. For that, just change that y variable in terms of t and writing this one in the form of dt by dx plus 1 minus n into that p of x into t is equal to q of x into 1 minus n. Right, thank you. So here integrating factor is e power integral 1 minus n into p of x. So that means here directly it is this one, 1 minus n is minus 5 into p of x is 1 by x, that is minus 5 by x into dx. Just evaluate that one, so that integration of 1 by x is log x, so it will be x power minus 5. So solution is t into integrating factor integral 1 minus n into q of x. 1 minus n is 1 minus 6, that is minus 5. Q of x is x, that is minus 5 into x. Integrating factor is 1 by x power 5. Simplifying that one, you will be getting this one. But if you see here, the solution is in terms of t, but we require in terms of y. That is the reason at the end, you should change this t with that 1 by y power 1 minus n. So y power 1 by y power 1 minus n, that is 1 by y power 1 minus 6, that is 5. Clear? This value should remember. Uh, just see here. Uh, just see here, this is the previous year question paper that is made 2019. So if you see this question, so you are given this like this: solve 1 plus x square dy by dx plus xy is equal to 4x square. Initial condition for x equal to 0, y value is also 0, you are given there. So you need to solve this one. So if you see here, dy by dx is multiplied with 1 plus x square. As this product is there, you should always remove this one. That means you should divide this total equation with 1 by 1 by 1 plus x square. Just see here solution. So like this, when you divide that one, it will be in the form of so dy by dx plus 2xy by 1 plus x square is equal to 4x square by 1 plus x square. Now if you see here, this is in the form of dy by dx plus a function in terms of x into y is equal to function in terms of x. That means in the form of dy by dx plus p of x into y is equal to q of x. Clearly it is a linear differential equation in y, where p of x is 2x by 1 plus x square, q of x is 4x square by 1 plus x square. So as it is a linear differential equation in terms of y, general solution is y into integrating factor is equal to integral q of x into integrating factor with respect to x. So integrating factor is e power integral that p of x, where p of x is 2x by 1 plus x square. Evaluation. So it is in the form of f dash by f of x. Derivative of 1 plus x square is 2x. So therefore it is log f of x, that is 1 plus x square, which is nothing but e power log of 1 plus x square is nothing but 1 plus x square. Integrating factor is this one. So y into integrating factor is equal to integral q of x, that is 4x square by 1 plus x square into integrating factor 1 plus x square. So this and this gets cancelled, remaining with 4x square. So integration is 4x cube by 3, and this will be your answer. Okay, so as I was telling you people, in generally he will be always going a bit of linear differential equation or a Bernoulli differential equation, and one question is compulsory from the application point of view. If you see the second bit, you are given this application of that differential equations. Clear? So that is the reason I was telling you people try to concentrate more on the linear differential equation problems and Bernoulli differential equation problems and Newton's law of cooling, growth or decay problem. One question compulsory, one bit will you have from these three problems: linear, Bernoulli, and application. Compulsory you will have a question. The other question will be from the first part as well as the second part of that equation unit, that is solvable for p or y, like that. Okay, so here if you see, this is that one. So third question you are given like this, so y plus y square dx plus xy dy, which is clearly mdx plus ndy format. So do y is not equal to, no, non-exact, non-exact, and it is clearly non-homogeneous. Degree of this y is 1, degree of this is 2, non-homogeneous. Therefore you should check for this next condition, either this one or this one. Okay, when you go for this condition not equal to f of x, therefore you should go for this condition. Like that you should go through them. Clear? Third question is that one. So third question second bit, if you see here, product to that dy by dx is there, so you should remove. When you split, it will be x by y plus 2y square. Now it has got changed into dx by dy minus x by y is equal to 2y square. That means this is a differential equation which is linear in x. Dy by dx plus a function in terms of y into x is equal to a function in terms of y. So linear differential equation in x, dependent variable x. So therefore integrating solution will be x into integrating factor is equal to integral this q of y integrating factor into dy, where integrating factor is e power integral this p of y into dy, where that is given as minus 1 by y. So it will be y power minus 1, that is 1 by y. Multiplying over here, x into 1 by y is equal to q of y is 2y square into integrating factor 1 by y. So simplifying this like this you will be having. So if you see here, the previous year question paper. Okay, so if you see